these are the three guys behind the gas laws that we're going to talk about: Boyle, Charles, and Gay-Lussac. Both between 1661 and 1801. These were the scientists who were working on these laws at the time. So Boyle's law is the first one, and Boyle's law is just looking at pressure and volume. So in this one, the amount and the temperature will be held constant, so they won't be part of the problem, right? We're just looking at numbers that are of pressure and volume. Okay. So P1 and pressure and volume are inversely proportional, and our actual law here is P1 V1 equals P2 V2. This is Boyle's law. Okay. So pressure is inversely proportional to volume. Remember, we had that syringe example. So if P increases, then our volume decreases, and if P decreases, then our volume increases. Okay. Charles' law is looking at volume and temperature. So pressure and N are going to be held constant. Okay, so we have V1 over T1 equals V2 over T2. Volume is directly proportional to temperature. So if T increases, then V increases. And if T decreases, then V decreases. Okay, and again, you will use Charles' law when we deal with problems that are just looking at volume and temperature. Okay, and these little K's, these are some constant. Okay, so volume and temperature are held to some constant. You don't have to worry about this so much right now. So Gay-Lussac's law is looking at pressure and temperature. So volume and our amount, our N, is held constant here. So again, we're not using those in our calculations. All right. So again, we have directly proportional. If T increases, if we have an increase in temperature, we're going to have an increase in pressure. And if we're going to have an increase in if temperature is going to decrease, we're going to have a decrease in pressure. And this was your aerosol can in your furnace or in a fire example. Okay. Okay. And these are directly proportional. Okay. What's more important is being able to look at these three laws or have these three laws readily available, so on your note card, and being able to figure out which law you need to use for which calculations. The combined gas law summarizes Boyle, Charles, and Gay-Lussac's into one equation, and that's P1 V1 over T1 equals P2 V2 over T2. Okay, and so it's used when none of the variables are constant. Okay, so N would be constant. Okay, but P, V, and T are all changing. So this is the three privates. Okay, PVT is private, right? If you a way to remember it, you're going to be able to use them when you do problems or on any sort of quiz. But if you needed to memorize it, PV is Boyle's law, right? VT is Charles' law, and pressure and temperature is Gay-Lussac. And you can see Boyle's is P1 V1 equals P2 V2. V1 over T1 equals V2 over T2 is Charles, and Gay-Lussac is P1 over T1 equals P2 over T2.